In addition to using percentages and decimals, the strength of a drug preparation can also be expressed using ratios, which are essentially fractions that have been tipped onto their side counterclockwise. This slide shows several examples of ratios that were made by turning the decimal form of percentages into fractions and then tipping the fractions onto their side. In the first example, 15% is converted to the fraction 15 over 100. Now 15 over 100 could be tipped on its side as is and used as a ratio strength. Just tipping to the left, we get 15 to 100 colon in the middle. However, it's better to reduce the fraction before reporting it as a ratio. To reduce the fraction, we divide the top and the bottom numbers by the largest factor that they both have in common. So for 15 and 100, 5 is a common factor. So we can divide the top and the bottom by 5. That gives us 3 on top, 20 on the bottom. 3 and 20 have no factors in common, except for the number 1. So this is our most reduced form, and we can tip it to the left and report it as the fraction 3 to 20, weight to volume. I'll let you pause the video and take a look at the next two examples if you like, which follow a similar pattern. One thing to know about a ratio is that the first number is the same as the top number in the fraction, and the second number in the ratio is the same as the bottom number in the fraction. And so the top number represents the amount of active ingredient or drug, and the bottom number represents the amount of total preparation. Also, the same as for percentages, the W refers to a weight in grams, and the V refers to a volume in milliliters. Because ratios are often expressing very small concentrations that don't look pretty as percentages, this slide outlines the procedure that you'd use to go from decimals to ratios. In step 1, you'd convert a decimal like this one into a simple fraction by just placing it over 1. That's the same number, it's just with a 1 in the denominator position. You then multiply the top and the bottom by a number that has enough zeros to eliminate the decimal. In this case, we can multiply by 10,000 to eliminate the decimal, moving the decimal over 4 places to give 25. And we'd multiply by 10,000 on the bottom as well to give 25 over 10,000 as our initial fraction. This is still equivalent to 0.0025 because we've just multiplied by 1. 10,000 over 10,000 should be still equal to the same value. Now we can reduce the fraction by, again, dividing the top and the bottom numbers by their greatest common factor. Now, if it's not obvious what the greatest common factor is, you can do this in multiple steps. For example, I noticed that 5 was something that both numbers had in common, so I divided the top and the bottom by 5 to give 5 over 2,000. And then I noticed that 5 and 2,000 could also be both divided by 5, and so I divided again to give 1 over 400. Now I could have initially divided by 25 over 25 to get 1 over 400, but I did it in multiple steps and got the same answer. Once we have our nicely reduced fraction, we just tip it to the left and we get our ratio strength of 1 to 400. Now if you have a calculator, one that's approved for assessments, non-programmable, and the calculator automatically converts decimals to fractions for you, then you don't have to think about these steps. You can just use the calculator. On the other hand, if you'd like more information, an additional explanation about how to convert decimals to ratios, then check out this link to the Khan Academy at the bottom of the page. and you can get more information there. Now, before you try some calculations yourself involving ratio strengths, here are a few worked examples. The first asks what 2.5% weight per volume would be as a ratio strength. So converting this percentage to a fraction involves putting the number over 100, the amount per cent, and we have a decimal in the top position, and so we multiply the top and the bottom by 10 to get rid of that decimal, move it over one place to get 25 over 1,000. Now we can see that both are divisible by 25, and so dividing the top and the bottom by 25 gives us 1 over 40, and that's our ratio. In the next problem, we go from ratio back to percent. We start with a ratio of 1 to 1,000, and we want to know what the percent weight volume of that will be. So we can tip the ratio back up into its fraction form, 1 over 1,000, and just divide that through to give a decimal, 0.001 grams per milliliter. Once the number's in decimal form, you just convert it to a percent by multiplying by 100. So you convert decimals to percentages by multiplying by 100, and you get 0.01%, and it's in weight per volume. In the final example, so the first two were conversions where we were going in the first from a percent to a ratio, and the second from a ratio to a percent. In this problem, we're actually using the concentration in a calculation. This asks how many grams of this cream are needed to provide 1 milligram of capsaicin. So first thing is that we have 1 milligram capsaicin, but we know that concentrations are expressed in gram units, in weight units of grams. And so knowing that there's 1,000 milligrams per gram, we can divide 1 milligram capsaicin by 1,000 milligrams and see that that is equivalent to 0.001 grams of capsaicin. And then knowing that, we can use the ratio in its fraction form. 7 grams capsaicin over 20,000 grams cream is what that ratio means. And we can use a proportion with the amount of desired capsaicin, 0.001 grams of capsaicin over X, where X is the total number of grams of cream that we would need to give that amount. Crisscrossing and dividing by 7 gives us an X value of 2.9 grams of cream. All right, go ahead and take a look at the calculations on the next page. Give them a try, and I will work them out myself in the next video. But try them first.